we got two parametric equation f of t and g of t. Firstly, our list plot is a built-in function of Mathematica, which is used to plot a list of coordinates. So here from the question, we already know the two coordinates, that is 2 comma minus 1 and minus 1 comma 3, and using parametric concept, using a simple mathematical concept, we figure out this coordinate. Nextly, we use this built-in function of Mathematica for the range of our graph. So we assuming that our axis start from -5 and ends till 5, both from vertical axis and horizontal axis, as you can see. Now expect ratio is used to set the ratio of what we are plotting. So that is automatic. We did it automatic. And this axis label, as you know, x-axis, this one, and this is your y-axis, so you label them this. Now for plot style, mathematical gives us this opportunity to tell the size of our points we are plotting. Now you can see the blue dots. If I put here if I increase this by 0.5, so the dots over here size will increase. Now what we did, g of t as a point that lies on both f of t and g of t. And for example, we want to know where the particle is at 1 second. Basically after 1 second uska coordinate kya hai. So when we input 1 second, so this is the coordinate where it will be after 1 second. In the next video I'm going to show you basically how the particle is moving, how the particle is the pad followed by the particle. Here all the commands are same as previously shown. So these are the coordinates as we know. So the one change that we made was in the C, so we could see how the particle. Now I'm moving the cursor. If you see the initial starting point was this, and how the red part is followed by the particle. In this question we are going to find the distance traveled by the function and the speed of function. So basically what we did, we knew the coordinates. H of t is a function that is equal to t, so graphics is used to plot a line. So a line, this coordinate we know from before, 2 comma minus 1. C h of b, c is used in Mathematica as a in which multiple functions can be obtained. If we, for example, we have g of t, f of t, so we just write by comma. We don't have to write the whole thing again and again. This and this axis, all the same thing. Now the red line is describing your distance and the blue line is your speed. Now I'm going to tell you how we found the distance. It is by the Pythagoras theorem. Pythagoras theorem, I'm going to show you in the next video the triangle we made it. So h square equal to p square plus b square. So we plug in the function value as we knew it before. So under 25, that's 5 h of t. Since 5 h of t is greater than or equal to 0, so now your distance is 5 plus h of t. Yeah, that means your distance is, like in the graph you can see that distance is increasing more rapidly than the speed. So we could say the ratio is 5 times. So that we are now plotting distance, speed, all the same thing. Blue is the speed, but it's just we are assuming that our distance is 5 times more than our speed. So over here we have label upper axis, distance travel blue, and speed red. So our speed that is starting from our origin 0, shown with the red line, and we're taking some random points over here. So in Mathematica we can show two different scenarios. I mean what scenarios means speed distance, मतलब दो अलग अलग चीजें हम एक ग्राफ पर दिखा सकते हैं. f of t and g of t over here, f of t and g of t. C of t in Mathematica is used to represent both function as previously मैंने जैसे previously वीडियो में इसको डेमोन्स्ट्रेट किया था. Now this is the case of a projectile motion followed by a particle. Manipulate, किस चीज को manipulate करना है, किस चीज पर we need to work out. Now we're making grid of the plot, a regular plot of our function. We are now plotting y coordinate as a function of time. Plotting as a function of time. Now मैं जब इसको run करूँगा, you're gonna get the idea. On the left we got the path of the motion. एक पार्टिकल हमने assume किया है वो किस तरह move on करेगा, ये वाला. और right side पर we got the y coordinate of function of time.